So here I'm going to talk about a consumption-based asset pricing model. The idea being that asset prices, in particular prices for things like bonds, depend upon the willingness of people to buy them and people to pay for them, and that willingness depends upon the individual financial conditions, right? So we are going to think about the individual's decision to buy bonds, right? They are going to buy bonds, which are going to be B, at a price PB, right? And a bond here is going to be something that is bought for PB and pays 1. Always, right? No risk involved in these assets, at least for now. So the individual's problem is to maximize their utility. And in general, that's going to have some utility function like this. But here I'll use a specific example. Perhaps they're interested in maximizing something like 3 log of C1 plus 2 log of C2, right? A very specific functional form. Now to do this, they are going to face budget constraints, right? And their budget constraints look something like this. In the first period of life, they can either spend money on consumption or they can spend money buying bonds at price PB. And the bonds they buy at price PB have to reflect their income Y1. So if B is positive, they are saving. If B is negative, they would be borrowing. The price of bonds is what it is from the perspective of the consumer, and so their income is split between those two things. In the second period, since life is ending, they spend all their resources, Y2 plus B, so they get the PB. The bonds mature at full value, and they spend it all on consumption. So what they're going to do here is differentiate, right? They need to take a first order condition. So the easiest way to do this is to reduce it to a problem of one variable by substituting in for B. So here we would get Y1 minus PBB plus 2 log of Y2 plus B. Now when I take the derivative here with respect to B, what do I get? I get 3 over Y1 minus PB times B times my chain rule term of minus B plus 2 over, that's Y2 plus B. I set it equal to 0. I'm going to bring one to the other side and cross multiply, and so I get 3 PB Y2 plus B is equal to 2 outside of Y1 minus PB times B. So this is what you could think of as basically an Euler equation, right? It's a relationship between, now I've rearranged it a little bit, but ultimately this is my Euler equation. So to solve now, I need to make one more conclusion. The idea here is in general equilibrium, and if all agents are the same, we must have PB equals, not PB, we must have the quantity of bonds is equal to 0, right? This is as like the sum of individual savings equals to 0 with no assets, right? If we were just living on a desert island and we were just giving, our money back and forth to each other, everyone's borrowing would have to be equal to everyone else's saving, right? There's no money from the outside the island. The same thing is true here, right? For society as a whole, net asset holdings have to be 0. For everyone who's lent money, someone else must be receiving that interest. So here, if I set B equals to 0, I get 3 PB Y2 is equal to 2 Y1. Great. And so my price of bonds is simply going to be PB is equal to 2Y1 over 3Y2. Now, if you were feeling, of course, adventurous, what you could do is differentiate this with respect to Y1 or Y2, and then you would have some idea of how PB varied with the state of the economy.